Hello and welcome to the Controller Talk podcast presented by Danfoss North America. Our goal is to bring you information about using Danfoss controls in the supermarket and warehouse industry, specifically in the US and Canada. We're doing these twice a month for now. You can catch these podcasts wherever you get your podcast, and it's also available through the Danfoss Ref Tools app. For the video version, check us out on the Danfoss North America YouTube page. Search for Controller Talk to see our video collection. I'm Dave Yoder, along with Chris Brown. So stick around and we'll have more information about listener mail and talk about March Madness and an important announcement at the end. So stick around for that. So Chris, seems like your Maryland Terrapins made it to the NCAA tournament, right?
You guys showed up pretty well at the end there too, huh?
That's right. Well, Penn State beat some team from Maryland right before that. Both made it in. Both got knocked out after the second round.
Come on, Dave. We both know it's baseball season now.
I guess that's what you're going with. Hope springs eternal for the Orioles again.
There you go.
Yeah, I see. All right. Well, you got rid of your offensive coordinator from the Ravens. Baseball's around the corner. It's all good.
We got something else to move on to when one starts getting depressing. That's all that matters.
Looking forward, not looking back.
That's right. That's right.
All right. Well, Chris, the last time we talked about calculations in our last podcast, and so just to recap, we talked about the max number of calculations, which is 96. That you can use them to clone a sensor, that they can be used to make decisions in the controller, that sort of thing. Now, on the YouTube version of this podcast, we'll superimpose some screenshots of some relevant calculations to give you a better visual, because this is going to be somewhat important to follow along. We'll use the AK255 screens because they're pretty basic and they are going to be a good size for this, and they'll show up better on the screen. So this time around, we'll look at some examples of how they are used and how they're built. Our examples will not cover all the options for sure, but we'll cover a few examples and you'll get a feel for how they work.
Yeah. And we'll start with a simple one, but also one that's used a lot, which is cloning points. A sensor, a digital input, a relay, variable output, whatever it is that you may need to use in more than one spot, you want to clone that in the controller. So when you're starting a new calculation to clone something, the units at the top of the screen, they're going to default to OI. And we'll talk about that in 1 second, but that may be something you need to change. And then there's also a line or a setting for your style, which defaults to generic, and we'll touch on that as well. But for cloning a sensor, and if it's a temp sensor, then the units are the first thing you're going to want to look at, and you're going to want to change them from OI to SI degrees Fahrenheit, because if you get 95% of the way through your calc and you say, oh shoot, I need to change my units up at the top, it's going to wipe everything out. You're starting over from scratch. So step one is to set the units when you're cloning a sensor to the units of the sensor type you want to clone, SI degrees Fahrenheit for temp, PSI for pressure, etc. So then the next line down for style, this is where you can get a little bit of a template that gives you a head start on building your calculation. Here you'd want to set your style to clone, and you'll see that does change some of the things further down in the calculation. The units are going to, like we said, the units decide what type of result you'll get from the calc. So setting them to degrees Fahrenheit means that the output of the calculation will be degrees Fahrenheit, just like a temperature sensor would be. That's how the program treats it. And then the style is kind of describing the basic functions of the calculation. So yeah, like I said, just set the units first. You don't want to have to do it later, and then everything gets wiped out and you're starting over.
All right. Yeah, because if you go back and change units or style, then it's going to start all over. Mm-hmm. Yep. Okay. Yep.
And style, but style, if you're doing it other ways, you may see that. I've actually seen that change because you're building a generic one to meet the template of something else. So
right.
If you're seeing the style option change as you're doing other things, don't get completely scared by that.
Yep. It's true. All right. So after setting the units to SI degrees F and the style to clone, we can pick an existing sensor to clone. Under data definition, we'll need to change it from not configured to the sensor that we want to copy. After that, all we need to do is add a description and delete a few blank lines that might be in there. And then at that point, it can be used as a temp sensor in the controller. assuming that you set the board point to calc first, where you want to assign it, and then you pick that calc from the list, and it'll only show you the ones that are available to pick from.
Yep. So, yeah, I guess if we kind of switch gears and look at a different example or a different type, something else that we see a lot of in the miscellaneous section with the calculations is just kind of a cut in, cut out setup. And so that's definitely something that we see a lot of in there. And so if we run through an example where we're doing this with a sensor and 2 set points to give us a deadband, we're going to use this calculation, this cut in, cut out setup to eventually control a relay of some sort. And so here you want to keep your units as OI because we're actually turning something on and off, which is the relay. So your units are still going to be OI. Your style, there is going to be a option in the drop down there to go from generic to cut in and cut out. And so when you make that change, you'll notice there's some things that are automatically going to populate in the rest of the calculation. By default, it changes, or it starts you out with a temperature sensor that you can pick from. Now you could change that to something else if you need to, a pressure transducer and what have you. But it starts you out with a temperature sensor that it assumes you're using for your cut in and cut out to compare against the 2 set points that you'll get. It does have to be a sensor that's already in the program. It can't be you're building this and you're going to add something that you wired up but you didn't already set up somewhere else in the program, whether it's under the miscellaneous sensors section or something that's maybe coming from the rack that you're using that's in that section. So you'll get your 2 temperature settings at the bottom of the calc, and that's where your decisions are made. So you'll get one line that's if the sensor reading's greater than one setting, and then another if the sensor reading's less than your second setting. Then it's comparing the sensor value against those 2 set points to decide when to turn the calculation on and off. And there's typically a gap between those 2 numbers, and that's where you get your deadband at so that you're not short cycling the relay.
Yep. And you can change the greater than and less than symbols, the settings, of course, you can change those, and the on-off positions at the bottom as much as you need to until it's something that works for you.
Yep.
By default, this setup simply says that if the sensor is greater than the num2 setting, the calc will be on. As the temperature drops, the calc will stay on until it's less than the num3 setting, and then it's going to turn off. Of course, you can change any of these settings for those 2 temperatures we mentioned, and if you need something similar that operates on pressure, like Chris said, you can change SI1, num2, and num3. You can change all of those from temperature to pressure.
Yeah. So we'll move on to one final example here, and this is another one that we see quite a bit, but this will be one where the style, or the type rather, is just a generic in the setup. And so using a signal from a calculation that's built to enable a subcooler is something that we come across quite often. So in this example, we're going to look at it in a way that we need at least one compressor to be running or to be on to enable the subcooler signal. Now, for us in this example, we're just going to look at the state of the compressor relays. Some guys might say, well, you should be looking at the compressor proof, and that's fine. We've done that in the past, but just for sake of this example, we'll say we don't have compressor proofs on this. We just have the compressor relay itself.
Right.
So we need the calculation to look at all the compressor relays, and then it's going to switch the calculation on when at least one of the compressors are on. So we'll need, in this example, 3 compressors. We'll need the 3 compressors to be listed in the middle section of the calculation where you're kind of bringing in your data to start to be able to make decisions later on. When you're in a calc, if you need more lines, there's kind of a bolder line that runs the length of the screen that stands out a little more than the rest. You just want to click on that line, highlight it, and bring up the drop down with a right click. And you can use that to add in additional lines in the middle section. So AKA 65 software, if it's a 255, you just right click right on that line and it'll allow you to add a new one in.
Yep. And in the bottom section, it'll list each relay output with the OR function. So we'll plug in those relay outputs and put an OR between them so it knows that if any one of those is on, that the calculation will be on. So the way it reads is if any of the relays are on, the calculation is on. The true line at the bottom will tell the calculation what to do if none of those relays are on. In this case, if none of the compressors are on, the calculation has to be off. And that's the purpose of the true line. And depending on your experience with logic and controllers and things like that, you could think of the true term as else as well. And that might make sense for some people.
Right. Yeah. And I mean, last podcast, we talked a little bit about the priorities of everything in the bottom section where your decision making's happening. So I guess if we stuck with this same example, the subcooler enable, and kind of use that to go a little deeper on that part. Let's just say we've got the subcooler enable calc, and we want to add something with a higher priority to keep the enable signal off. So maybe the compressors are running, but if there's a phase, for some reason, it's calling for the compressors to run, but we have a phase loss input, which should be shutting the compressors down, but maybe we want to build that into the calc just to be sure. And if that phase loss is on, then we want to shut the subcool enable off as well. So that would be that digital input for the phase loss, which is already going to be in the program. That would be added into the middle section where we're, again, bringing in all of our points to be considered. And then when you drop down to the bottom part of the calculation, you want to make sure that the first line is the line where you're referring to the phase loss point, because, again, it prioritizes things top to bottom. So by having that phase loss point listed first, the way the calculation's written, it implies basically that if the phase loss is on, the calculation has to be off, and the rest of what's going on in those decision-making things is irrelevant.
Yep. All right. And as we said last time, if you want to experiment with calculations using AKA 65 Simulator, that allows you to create them and you can test them all offline. And we also mentioned that if you get stuck, you can always send your whole database file or even just some screenshots to us at ControllerTalkNorthAmerica at danfoss.com, and I'll take a look at them and give you some feedback.
Yeah.
Okay. So, Chris, it's time to ask you a question.
Yeah.
Yeah, the part you can't wait for. Your wait is over. So I'm going to tell you up front, this is probably an unfair question, but it's somewhat relevant.
As opposed to the other ones.
Well, you know. Anyway, yeah. So here's a question about the 800A. It came up recently, so why not pass it along?
All right.
So under what situation would a user enter his username and password and it's actually correct, but it doesn't work?
It doesn't work.
Yeah.
So it doesn't work, meaning
he can't log in with it.
He can't log in with it.
But it's actually correct. Like I said, this is an unfair question.
I will take a random stab at this one and say if somebody had configured his access level with all disabled.
Well, I think that's possible.
Maybe.
Sure. The answer I was looking for is in this situation, the user couldn't log in.
Mm-hmm.
So he asked me to check it, and I logged in remotely, no problem. I checked it all out. I said, I see no problem. And then he sent me a picture of his login screen showing his username, and he had put a space in at the beginning.
That'll do it.
Yeah, that will do it.
Okay.
Yeah. So just a word to the wise out there. If you're getting frustrated and you think it should work, then just check for those little details.
Yep.
Because there should be no space at all at the beginning there. It'll mess you up.
Yep.
All right, Chris, we have some feedback, what I would like to call listener mail, from our episode 2 back. Yeah, something like that, on the HGM interface.
Yep.
With the Beckerman leak sensor. And so one of my contacts, my unnamed contacts over at Bacharach.
You've got a guy?
I've got a guy, yeah. Always need a guy. So I mentioned that the infrared bench in the HGM is photoacoustic. And some of them used to be, but in the HGM MZ, it's actually a little different. It's called a non-dispersive infrared technology. You were probably thinking I was wrong about that anyway.
I was going to let it slide.
Yeah, well, you did until now. Yeah, thanks. So yeah, there is a little bit of a difference on the technology there. So that probably means that the HGM MZ is a little bit better technology and a little smarter. So that's probably something we can assume. And then I also mentioned that if you are looking at how it sends out its zone information on that little 4-wire interface we use we said that it sends it out as a 4 to 20 milliamp signal, and then we put resistors on there to give us a 1 to 5 volt DC signal that we can read. And I think I said that if you had 8 zones, it would divide that whole voltage range up by 8, and then that's how it knows which zone it's on. But it's a little different. It of course it sends it out as a 4 to 20 milliamp signal at first, but then it's a fixed scale, and 5 milliamps is going to be zone 1, 6 milliamps would be zone 2, and so on, and then it gets up to 20 milliamps, that's zone 16. So if you're really hardcore and you want to put a little amp meter on there that can measure milliamps and you're in series, you could actually see it go from zone to zone.
Yeah.
Yeah, I bet you were always wondering about that.
It's good. I mean, you never know when it's going to become useful, so
that's right.
It's good to know.
All right, and the final point was kind of off the board here, but it came up recently, a question about exhaust tubing. And in the north here, where sometimes it gets freezing in the winter, not this year, but sometimes. But
it got cold. It just never snowed.
Well, that is true. There's a difference.
Yeah.
So in the installation of your HDM, you're supposed to tube out an exhaust port. And the idea is that you're taking the samples that come through the photoacoustic bench or infrared technology, whatever the case may be, and you push that sample back outside so that you don't introduce that refrigerant to anything that you're sensing. But in the north, when that warmer air goes outside, it condenses and freezes right away. So that's kind of a problem.
Yeah.
And then you'll have a fault on your leak detector. So just from some anecdotal discussions with people that have installed these, what they'll do is they'll run that tubing into a separate room that's not being sensed. It could be a generator room, electrical room, sprinkler room, something like that. On the off chance that there's some refrigerant that's going to end up there, at least there won't be a sensor nearby.
Yeah.
So you'll have an alarm somewhere on a zone, but you won't have a secondary alarm by pumping it into the same room.
Right.
Yeah.
No,
So,
it makes sense.
yep. Just one of those little tips. Yep. All right. So if you'd like to drop us an email with a suggestion for topics to cover, or a question or comment, you can always email us at ControllerTalkNorthAmerica@danfoss.com. And also, I wanted to mention that the podcast is going on hiatus for a few months. And I think we'll come back probably, at the end of the summer, after Chris has had all of his vacations out of the way. And yeah, you should go to spring training.
It's not the worst idea.
That's right. But yeah, I think we'll come back at the end of the summer with some new podcast, and we'll get into some CO2 stuff, which we promised this year.
Yeah.
And we'll come back renewed and ready to roll.
It's nothing better than anticipation, so I'm sure everybody will be eagerly waiting to hear us again.
That's the idea. Yeah, got to keep them wanting for more.
That's it.
Until next time, for Chris Brown, I'm Dave Yoder. But wait, we forgot to give credits. Yeah. Our studio and video engineer is Michael, don't call me Mike Beckerman, but he's not even here right now. Our audio engineer is Raul Garcia. And Maria is back from India, I hear. And she is the backbone of this whole operation. And our new guy, Josh, no idea. He's MIA. But we're making it happen, though. So, until next time, for Chris Brown, I'm Dave Yoder. Stay cool.